Hi, my name is Ryan Shelton. I work with Group Unlimited, who's the distributor for DiGiCo here in the US. So this is the first workshop with DiGiCo. We're actually going to focus on digital consoles, unsurprisingly. We're also going to focus on how they work as systems. So I'm going to go over that in just a minute. All right, real quick, Group Unlimited, as I mentioned before, they're the distributor of DiGiCo, but they distribute a lot of other brands, including Blue Sky, Calrec, Clang, XT/MC², and most recently SSL. All right, our first workshop, we're going to discuss digital consoles. How some digital consoles are designed to simply be a digital version of an analog console, and how some consoles are designed to be part of larger systems. We're also going to talk about how DiGiCo can make it easier for your church or organization as it grows. The goal of this workshop is to give you an overview of the DiGiCo ecosystem, briefly show you the hardware, and show you how you can configure these systems to specifically fit your needs as you grow. All right, a little bit about DiGiCo real quick. DiGiCo is based in the UK. They were actually founded in 2002 with the launch of the DiGiCo D5 Live. Coincidentally, we still have quite a few in operation around the world. All right, so they're based in the UK and they actually manufacture, test, and do all the things with the consoles in Scotland. All right, the purpose of DiGiCo is to design consoles that are well thought out for every mixing application and designed for the art and science of sound engineering. This means whether you're doing live, whether you're doing touring, church or house of worship, whether you're doing broadcast or whether you're doing theater, that's what these consoles are designed for. They are not a recording console. They are not meant to be put in a studio. They can handle some of those tasks, mainly multi-track recording, virtual sound check, things like that. They can handle those functions, but they are designed for live mixing applications. They're also designed for the sound professional. Now, before you think maybe this isn't for you, keep in mind that professionals need reliability, flexibility, and speed. They need to be able to get around the product quickly. And that doesn't just mean they know it well. That means that everything is logical. It's also optimized. So we know how you're going to use this. And to be honest, we actually cheat a little bit at this, and we have a network of engineers that we reach out to as we implement new products and new functions, and back to when we first built this software, to make sure that we're not putting in any unnecessary steps, any unnecessary menus or options. We're trying to keep this as streamlined as possible to make it fast and easy and functional for you. All right, let's talk about some of the common features you're going to see across our product range. The first and foremost is premium sound quality. This is of huge importance to us. We don't have time today to go through everything, but I just want to hit on one thing: floating point processing. This is huge for us. So we use 40-bit floating point processing across our entire product range. That is very important because it is the most natural, high-definition way to process large amounts of audio channels and to sum them together. Now, you'll all see a huge difference between our platform and a number of other manufacturers that use fixed-point processing. Fixed-point processing is a more affordable way of doing things, but as you start adding more channels or you start demanding more of your console, you're going to hear that things may sound squished or just not as detailed, flatter. That's often common things that we hear from our users. You're also going to see that we have a logical software workflow. As mentioned before, we work with engineers to optimize our user interface, or graphical user interface, or typically called a GUI. And this means that we are limiting the number of pages you're getting to. We're also trying to give you an overview and direct access to the controls you're going to need. You're also going to see that our physical consoles have an ergonomic and flexible layout. This means that the console is never wider than you can actually reach. You don't have to slide your chair back and forth to reach the different sections of the console. The faders are very comfortable position. The screens are close where you can reach them. The encoders are all in a very logical and ergonomic layouts. This takes a lot of experience. We've designed a lot of consoles over the years. Also, one of the main things we're going to focus on today is scalable architecture. What this means is that you can invest in a console and a stage rack now, and then as you grow, as that facility or room grows, you can actually add on more stage boxes or more consoles, and I'll go into this in more detail in a minute. Lastly, we're going to talk about return on investment. This is something I feel is very unique to DiGiCo. Just to give you an example, we launched the SD9 back in late 2009. When that console was launched, it was a 40-input, 16-bus or 16-aux console. It later went to a 48-input, 24-aux console, and then now today, not only is it fully supported by our software updates, it is a 96-input, 48 aux console. This is a huge investment and a huge change just for you owning the same hardware. If you bought that original console in 2009, just through software updates, no hardware, you would be up to that 96 input channels right now. So that is something that I feel that we offer and value that we offer our users. All right, let's talk about what is a console and what is a system. And I'm going to start with the usual. I'm going to start with our analog consoles because that's usually where everything started. So here we have a stage with microphone inputs, and those are wired back to an analog console. You probably have rooms or facilities throughout your campus that are just like this today. So you have an analog console, XLR connections on the back of it. You may go through an analog snake to go up to the stage, maybe floor plates, floor pockets, or wall plates, depending upon who integrated your system. All right, so a digital console, when they first came out, were simply designed to replace that analog console. Use all your existing analog infrastructure, and this is how a lot of them are made today. All right, more recently, you've seen digital stage boxes. Some of them actually have the DSP inside of these, but more commonly, the DSP is inside of the console, and the stage box is just that, a stage box. And then we simply connect those lines on the stage, whether that's floor pockets, wall plates, or directly to the stage box, and that stage box connects to the digital console via Cat5e or Cat6 lines. It may be coax, it may be fiber, depending upon the infrastructure. This makes it very easy to install into retrofit installations because it's a very simple cabling run from the digital console to the equipment room or to the stage. Now, as far as a system goes, this is what I'm trying to talk about today. A system is not just a digital console and a stage box. When you grow and add more microphone inputs, you need more stage boxes. And you can add these later over time. And as you add more inputs and you need more stage boxes, you can add more I/O over time. And to truly make it a system, we need to be able to add another console to this setup. So maybe right now you're focusing on a broadcast or a streaming mix, and you would like to easily add in a console that can see all the I/O from the stage, that maybe as a mic pre gets changed by the person at front of house, can be automatically compensated at that broadcast position, have its own DSP, and set up an optimum mix for the stream. So that's what I'm talking about by a system. Something we can add to over time, add more consoles, and you know what? Let's throw in a monitor console. So now we can actually mix for the people up on stage. Maybe we don't want them fooling with Avion mixers while they're supposed to be performing. All right, now more commonly you're actually going to see this connected up via a Cat5e or Cat6 switch in Cat6 cabling, all to a similar switch. That would be something like Dante, which is quite popular today. All right, now we have some terminology out of the way and we have some common understanding. Let's talk about the DiGiCo ecosystem. We're actually going to do this through a series of system examples. This is example number 1, and this is going to be based on the DiGiCo S series and Dante as an infrastructure. Quick overview on Dante. Dante is an Ethernet-based IT digital audio networking protocol, commonly called AV over IP, so audio video over IP infrastructure. So that means we can take standard Cat6 cabling, standard Ethernet gigabit switches, and we can connect all the devices together in what we would call a star configuration. So I/O boxes on stage go to the switch, the console goes to the switch, everything talks to each other, and we set everything up and we route via software. All right, so now that we have an overview over Dante, let's build a system out. So first I want to introduce you to the S31. The S31 is part of the S series family. There's an S31 and an S21. The 21 has less faders and 2 screens, and the S31 has 3 screens and more faders. Same DSP availability between them, just one's a more smaller and compact console. So the S31 has 48 Flexi inputs, and it has 16 Flexi buses. A bus, remember, is an aux or a group, and you define how those are set up. Flexi means that any channel or any bus can be mono or stereo. So as an example, if I needed a stereo input for my music playback at front of house, I would plug my computer to play back 2 channels of audio into my console, so 2 mic pre's, but then I'd go to 1 channel on my console and make it stereo. That 1 stereo channel is going to look at 2 mic pre's, but it is taking up 1 channel, and all 48 channels can do this. That means I could have 48 stereo channels if I truly needed it. All right, same thing with the buses. If I set up a mono wedge mix for a musician, we later move to mono ears, and then we decide to get stereo ears, I would simply go to that aux and change it to stereo. I would need 2 outputs from the system, and obviously my stereo in-ears would need to be able to accommodate that, but the console will easily be able to handle that. All right, you're going to also see 31 motorized touch-sensitive faders. You're going to see RGB backlit touch-sensitive encoders. What this means is we have an LED ring that can change colors around every encoder. So as we select a parameter like mic pre's or auxes to control on the console, the encoders will actually change color. We also have virtual on-screen macros. Macros are a lot like launching an app on your smartphone. They do a bunch of common commands for you, and it looks like an app on your smartphone. So this is an on-screen button that you press that can do things like save your session, update a snapshot, maybe tab tempo, or something as complicated as move every input into virtual sound check mode and back. All right, you're also going to see that we have 3 capacitive multi-touch high-res displays. These are beautiful, very easy to view and very easy to control. It's a lot like interfacing with an iPad or a tablet. All right, let's show you the back of the console so you can see how some of the I/O is on this and how we're going to connect in the system we're going to build up. So first things first, you're going to see that we have 24 mic pre's on board. These are completely flexible and completely routable to any channel anywhere in the system. And they're also continually available even if you're using the other methods of connection to like audio stage boxes. We also have 12 analog line outputs. And then you're going to see we have 2 DiGiCo multi-channel interface card slots. We commonly refer to these as DMI slots. These are each 64 by 64 channels at 48 or 96K. That means with these 2 card slots, we can have 128 channels in and 128 channels out if we needed to. That is not counting the already 24 mic pre's and 12 analog outputs that we have. Everything is fully routable and flexible wherever you need it to go at any time and can be recallable via our snapshot system. You'll also see that we have a 48 by 48 channel USB audio interface. We call this a UB-MADI. That means we can connect a USB cable directly from our computer at front of house to our console, and we can multi-track record directly from this interface, up to 48 channels, and we can also play back up to 48 channels as well. Lastly, we have an AES pair of in and outs. That means we have 2 channels in and 2 channels out via AES right on board. Now, back to those DMI slots for a second. We have an amazing assortment of cards that go in there. Anything from standard analog and mic pre, line in, line out AES cards. We also have things like MADI over Cat5, MADI B and C. We have Waves, we have Dante, we have Aviom, Allen Heath, we have a Clang card. Basically, any format that you could want to talk to, these consoles and these card slots can do it. All right, so let's build up our system with the S31. So we're going to put this S31 at front of house and we're going to put in a Dante DMI card into one of those card slots on the back. Then we're going to add 2 of the A168 stage boxes. So these actually go in wall and they're meant to be installed in your facility, in the wall. They actually combine a wall plate and a stage box into one. They mount in standard back boxes and the power can be hardwired. Now the cool part about these boxes, not only are they in wall, they also have dynamic LCD labels. So that means that as you route and patch things throughout Dante, those labels are actually going to show up on the LCD boxes themselves. So if your volunteer has any questions about where to plug in a guitar or a vocal, it'll actually say it right there on the box. So this is incredible and a very powerful box. Each of these boxes has 16 inputs and 4 outputs. So with these 2 boxes that we have here, maybe mounted on stage left and stage right walls, this would give us 32 inputs and 8 outputs. Everything, as you can see, is connected to a Dante-enabled switch or a Dante-compatible gigabit switch back to the console. And we have audio going in both directions. We patch everything and set it up in Dante Controller, and we're good to go. Now, as your facility grows, we might want to actually add another one of these boxes. And you might not do this after the fact. You may want a portable solution. I'll show you that in a minute. But here we actually have another in-wall box. And it's really as simple as this. We just connect everything back to the existing switch, and we can continue scaling up from there. This would give us 48 inputs and 24 outputs. All right, maybe you have existing wireless microphones already. These can simply be plugged into the mic pre's on the back of the console if they're already at front of house. If they're at the stage, you can plug them into stage boxes, or if they're Dante enabled, we can bring them to the same switch. So maybe as you upgrade your wireless microphones, these things can reside in a rack mount enclosure, connect to the same switch, and be routed through Dante software back to this console. Everything can be controlled through there. Now, as I mentioned before, if you want a portable solution, we can do the same thing with the A168 Dante-enabled stage rack. This is a true 16 by 8 throw-down rack. It doesn't have the cool LCD labels, but it's got the great audio quality and the portability to go with it. If you need a more traditional installed rack mount solution, we have rack mount kits for those boxes as well. All right, let's take a look at system number 2. This is actually going to be based on DiGiCo's SD series platform, and the infrastructure is going to be MADI. If you're not familiar with MADI, MADI is a point-to-point system. It's not designed to be a network or a star like Dante is. It's designed to go from one device to the next, and it's designed to be incredibly easy. In fact, there is no software for it. You simply connect them together and they work. It truly is that easy. That's why we like it a lot for a lot of our portable and touring systems, as well as just a very basic install system. You're going to see here, though, that we can actually scale this system up to quite a lot as well. All right, so MADI is also sent over coaxial cables. Typically, it does have an option for fiber, but typically coaxial cable, and it's going to give you about 64 channels at 48K. Now, to introduce this system to you, I'm going to need to introduce the SD12. The SD12 is a large format mixing console. It's 96 inputs. It has 48 output buses, 24x2 motorized touch-sensitive faders, RGB backlit encoders, as we mentioned before, and then 5x5 macros. What that means is there are physical buttons for our macros this time with LCD scribble strips, but that means we have 5 banks of 5, so a total of 25 macros. Remember, those can do anything from save your session, tap tempo, update a snapshot, or mute specific inputs if you need them. All right, let's take a look at the back of the console as before to show you how audio gets in and out from here. First things first, we have our 8 mic line inputs, 8 analog line outputs, and 8 channels of AES in and out over 4 pairs in and 4 pairs out of AES. We also have 2 MADI ports. Each of these MADI ports are 64 by 64 channels at 48K, and we have 2 of them, which you're going to see. We're going to use these in a minute to connect to our stage racks. We also have 2 DiGiCo multi-channel interface card slots. So as before, 64 by 64 channels at 48 or 96K. We also have a USB audio interface, the USB MADI as before, so that's 48 channels by 48 channels at 48K. And then we have 2 optional optocore loops. So the first one is pretty standard on the SD12, but it is an option, so you can either choose to get it or not, and it depends on your infrastructure. In fact, everything within the SD series line can have optocore added to it. You're going to see an optocore in a minute. I'm going to explain that in system number 3. It is a fiber-based loop system, and this SD12 or any of the SD series could be part of that system. All right, so let's build up our system. We have an SD12 at front of house, and we have a D2 rack that is connected via 2 MADI cables. These are SDI lines or RG59 or RG6. Your video guys are used to these, and they just run 1 send and 1 return from the console MADI port to the D2 rack. The D2 rack is 48 inputs, 16 outputs, and has 2 output option card slots. These give you, can be AES, analog, or Aviom, depending upon what your needs are. Now, as your system grows, we can simply add another rack to this. So 2 more lines, send and return from front of house on that second MADI port back to this console. So now we have 96 total inputs on the stage. We still have our local inputs and outputs with the SD12. I told you this was point to point, and we want to add a broadcast console. So let's throw in another SD12. Now we simply take a split off of the D2 rack, and we're taking 1 coax line from each of the D2 racks directly to the 2 MADI ports on the SD12. Now this doesn't actually have to be an SD12. This could be something like an SD9, anything else in our SD range or the quantum range, or even that S31 I was showing you before could have a MADI card put in, and we could connect to these stage boxes as well. All right, now you're probably, as you're growing, going to need to move the musicians on the stage to some form of personal monitor mixing system. Now, we can do that with something like a Klang DMI card. Remember, this console has those slots on it. So Klang is a personal monitor mixing system that has 16 mixes, 64 inputs, and not only provides the standard mono or stereo option, it provides an amazing immersive 3D mixing option for the musicians as well. Incredibly intuitive interface, iPad, iPhone, tablets, however you want to get in and out of that system and control it, you can. There's actually physical controllers coming for that later this year. Now, if you have an existing Allen & Heath mixing system, like the ME1 or the ME500, you can connect those up via ME card. There's also an Aviom card, or if you're just using some other manufacturer, they probably have Dante, and we can just stick a Dante card in there as well. All right, so let's talk about system number 3. This is based around DiGiCo's Quantum series platform and optocore as infrastructure. So Quantum series is our flagship series of consoles. We have the Quantum 7, the Quantum 5, and the Quantum 338. Let's talk about Opticore though first. Opticore is a fiber loop-based system, as I mentioned before. Now, Opticore is pretty cool because in a loop, you go from one device, connect to the next device, to connect to the next, connect to the next, connect to the next, and back to the first. And then if you need to add a device, you simply break a connection, add a device, and connect those back together. So you can scale this system up very easily just by connecting things into the loop. So it is a redundant loop. That is the other thing that makes this awesome, and that's why we fully complete it, because it sends audio not only in the primary direction, but in a redundant direction simultaneously. And then the software on the Opticore cards will choose which ring it's actually taking. So if a console gets turned off or disconnected, then audio and control will still flow completely around the ring and around that disconnected device. It allows for 5 consoles, each with redundant engines, and it allows for 14 I/O racks. This is amazing. That's a lot of I/O that you can scale up to. Remember though, most people start with 1 or 2 devices and then scale it from there as you need it later on. So these I/O devices can be like our SD rack, which I'm going to show you in a minute, the mini or the nano version of that SD rack. There is a D rack, there's an orange box, there's Opticore R series boxes. All of those can reside on the same network. Now, this network allows for a total of 504 audio channels at 48 or 96K. That is one of the primary reasons people look at this solution. It is difficult usually to move around 96K with a significant number of audio channels. And this platform has no penalty for doing so. All right, let's dive in and introduce you to the Quantum 338. The Quantum 338 has 128 inputs, it has 64 output buses, and it provides 64 channels of nodal processing. Nodal processing is something exclusive to the Quantum, and what that does is it allows you to have full EQ 4-band parametric with dynamic control, so dynamic EQ. It allows you to have a compressor and a gate or any combination of Dynamics 1 and Dynamics 2 applied to a specific node, aux node of a specific channel. What this means is instead of double patching channels, maybe you have a lead worship or lead vocal worship leader channel, and you might have a channel for their ears, you might also have a channel for the house. And instead of having to double patch those and run 2 channels, most people are only doing this if they have the channels available. You can actually do all this from a single channel. So I set up one channel that's going to my house, and then I can choose that nodal processing and turn on a specific EQ and dynamics, or maybe no dynamics more importantly, to go to that worship leader's ears. All right, we also have 36 by 2 motorized touch-sensitive faders. We have RGB backlit encoders. We have 10 macro LCD buttons by 4 banks, so a total of 40 macro LCD buttons. And then we have capacitive multi-touch, daylight viewable, high-res displays. And these screens are big and beautiful and clear and very easy to navigate around on as well. All right, as before, let me show you the back of the console so you can see how audio gets in and out of here. Now, first things first, we have our onboard local I/O, 8 mic pre's, 8 line outs, and 8 channels of AS in and out. Now, the analog I/O on here is very special. It's actually our 32-bit mic pre's. These are premium Stadius pre's, and they are built into this surface. It is exceptional how low noise and how high detailed these mic pre's can be. All right, next you have our 6 MADI ports. Each of these MADI ports is 64 by 64 channels at 48K. Then we have our UB MADI interface. So this is the same USB audio interface I showed you before. We have 2 DMI card slots, and then we have a dedicated Waves I/O port on here. This is 64 channels of Waves at 96K. You also have Opticore as standard on the Quantum series, and then you have Opticore, a second Opticore optional loop. That means if everything I told you about Opticore was not enough, you can do this times 2. All right, last we have fully redundant power supplies. We have this on the entire Quantum range and the SD range as well. That means you only need one power supply to operate. The second one is fully redundant, and that can be either or. We recommend putting one on a UPS. So if you do have a brownout or you have some sort of power issue at the facility, you'll have seamless running of your console. All right, let's build up our system. We're going to start by putting a Quantum 338 at front of house, and then we're going to add a Quantum 338 at broadcast. So once again, these don't have to be the same console. I'm just doing this for ease of PowerPoint building, but this could be a SD console, this could be a Quantum console. It really doesn't matter. Put what you need where you need it. Now we're going to add 2 of our SD racks. These are our premium modular racks. These have 7 input card slots, 7 output card slots with 8 inputs or 8 outputs per card slot. So that means we can have 56 in, 56 out per rack. The 2 we have here would give us 112 inputs on the stage, plus we would always have our local inputs and outputs available to us whenever we needed it. All right, next we're going to connect these all up via a fiber loop or a fiber ring, as we talked about before. This means we're going to take fiber between device to device to device back to the first. That'll give us a redundant loop. Next thing we're going to add is something I haven't introduced you to yet. This is called a 4x4 system. The 4x4 system is essentially 4 small digital audio consoles crammed into a centralized DSP housing. So it has some audio I/O on it, but it's actually meant to have remote I/O and remote control as well. And I'm going to show you that now. What we can use this solution for is actually being a standalone centralized mixer for multiple smaller venues across your campus. So let's stick some I/O across our campus. We have our A164 Dante-enabled wall LCD boxes. We have our A168 Dante-enabled stage box, and we have some Dante wireless microphones. Those are all connected up to Dante via Dante DMI card into the 4x4 system. Now, we can have an opticore DMI card as well in that 4x4 so it can ride on the same network. That means I could take Dante from those wireless microphones, I could put it onto the opticore network, and then those front of house and broadcast consoles could not only see any of those I/O boxes that are connected via Dante, but they could see the stage inputs as well. In fact, they'd have all of them available to them. Next, let's add some controllers. You're going to see me put a controller in things like your fellowship hall, your chapel, your children's room, and some in-wall encoders for the lobby volume control as well. You can also have Mac or PC control, and you can have iPad control as well. All of these controllers can be set up to show you just the channels, the mixes, the auxes that you want the operator to see. They're also PoE powered, so we can connect them to PoE switches, and we can just simply plug them in when we need control, maybe part of a portable cart or in-wall solution. All right, finally, let's add a monitor mixing console to this loop. So once again, remember, we can add more I/O, we can add more consoles simply by breaking the loop, adding in the device that we need, and now we have 3 consoles, front of house, monitors, and broadcast, all in the same loop, getting to see all of this same I/O, as well as send audio back down the loop as well. All right, that's basically it for us. Thank you so much for taking the time to spend with us. Maybe learn a little bit more about DiGiCo, maybe learn a little bit more about digital audio systems. Thanks for joining us. I'm Ryan Shelton.